So hello everyone and I welcome you all to Rankplus JEE English. In today's video, I'm going to cover a unit electrostatic in which there are two chapters, electric charges and field and the electrostatic potential and capacitance. So we are going to do the complete theory, complete previous year questions from JEE 2024. So there are so many things which I'm going to cover in this class. So do not miss this session. And the PDF of this session you will get on our Telegram group. So if you haven't subscribed or following our Telegram group, you have to do that. And the link of the Telegram group is in the description or and also in the chat. Okay, so you can go for that Telegram group. There you will be getting the DPPs, exclusive notes, and the important notification about the exams. So this is particularly the syllabus of our this unit electrostatic as per the JEE Main 2025. These are the topics which I am going to cover in this one shot. So in this class or in this session, I would be covering the complete theory. First thing, I'll be completing the theory. Second thing, I'll be discussing some very important pattern of questions which are coming again and again in your JEE Main. And once we are done with these two things, the theory and the important patterns of questions which are coming, I'll test your knowledge regarding this from JEE 2024 PYQs. So in this, I have included the January session as well as April session. So this is going to be our flow for this chapter. So first I will cover the theory. Second, I will cover the important patterns of questions. Topic wise I'll be going, okay, and once we are done with this, I'll be covering the previous year questions from JEE 2024. And after watching this lecture, I would be suggesting you to go for the daily practice paper which I'll be sharing, and the second one is go for the at least 5 years PYQs. We will also going to cover those previous year questions in our new series which will be coming, but it will take 1 week or 2 weeks. But before that, you can go on your own. Okay, I would want that you would be doing your practice on your own. So let me start. Please share this session with your friend, guys. Gua, what is your real name, Gua? Kulla Money Gaming, hello. Vijay Roshan, hi. So shall we start our session? So let me start this session with a very basic thing, because this chapter is also important for your board exam if you are giving the board exam this year. So electrostatic, let me start with the electric charges and field first, then we will move toward the electrostatic potential and capacitance. So in the electrostatic chapter, we have to study that what is charge. First thing starts from the charge only. So for starting the charge, let me tell you a very brief story that on this universe, we are having the human being known as scientist. They are very good observer and they observe everything and they look for the pattern in everything, right? And they find out that in this universe we have only two things. First, matter, and the another thing is energy. So these scientists observe that on this planet or on this complete universe we have only two things. First one is the matter and the second one is the energy. And even Einstein gave us the equation that these matters and energies are interrelated, you know, from an equation E is equals to mc square. We are not going into that. We will go in this equation in dual nature, or you would say that in the modern physics. But here my main concern is that now we know that matter is actually made up of atom, and atoms are further divided by subatomic particles. There are subatomic particles which we have to consider, and in our syllabus basically we have to study only 3 subatomic particles, which are protons, electron and neutron. So these are basically fundamental building blocks for any matter which we are seeing in this universe: protons, electrons and neutrons. We provide a symbol for them. Proton is generally be denoted by P, electron by E, and neutron by N. And we got to know that if we are going to calculate the gravitational energy, because we know that matter is anything that has mass and occupies space, right? That is the basic definition you have studied in your previous classes, that matter is anything that has mass and occupies space. So we know that there is a mass for this proton, there is a mass for this electron, and there is a mass for this neutron. So I'm going to write that the mass of proton is 1.67 into 10 to the power of minus 27 kg. The mass of electron, it's very less, 9.1. It's a 9.1, 10 to the power of minus 31 kg. Okay. And the mass of neutron, it is almost similar to the mass of proton. Okay, the mass of proton and mass of neutron are almost similar, 1.67 into 10 to the power of minus 27 kg. Now, if somebody wants to calculate the gravitational force, if you want to calculate the gravitational force, which is equals to G m1 m2 by r square between two protons, if I'm considering two protons, there is one particle proton and another particle proton, and they are separated by a distance r. If I tell you that you have to find out that what is the force between proton and proton, earlier we know only about the gravitational force. So somebody was doing the calculation and got to know that proton and proton must be attracted, right? Because in gravitational force we got only attraction, right? Due to the masses could only be attracted, right? Because when there is mass, another is also having a mass, we know that gravitational force is the only attractive force we are having. So if there is proton, another proton is there, we got to know that theoretically they must be attracted, but practically we got to know that proton and proton repel each other. So there must be some another force which is acting between proton and proton, right? So that was the question at that time. So we got to know that other than mass, there is another property which exhibited by the proton, and due to which we will see that many phenomena will rise. So that property is charge. Very fundamental basic property. Every matter is having a charge. We will see that. So this proton is having a positive charge. And the value of that charge is, what is the value? 1.6 into 10 to the power of minus 19 coulomb. Electron is having a negative charge, and the value of this is 1.6 into 10 to the power of minus 19 coulomb. This do not have any charge, neutron do not have any charge, and there is no charge. We will not be discussing anything about neutron. It's a very good I would be saying a candidate about which we would not be saying anything in this chapter, neutron. Okay. Now we got to know that there is a special property, a fundamental property in proton and electron. They are also having some extra property which is known as charge. What does scientists do? Scientists first observe and then give a fancy word to that, right? What is mass? Mass is also a fancy word, right? It basically defines some property of inertia. So similarly, we are having a charge. It is a fundamental property due to which any matter could experience the electric and magnetic phenomena and could generate the electrical and magnetic phenomena. This is the simplest definition what I could do. Now, these are the charges what is there, and also due to this charge, which is a fundamental property I am saying, due to this charge, we are going to see that there are so many phenomena we are going to study in our complete part 1 physics. Okay. Now, in electrostatic, we are considering that this electric charge is gonna to be at rest. So if this electric charge is at rest, there are some phenomena which we have to study. Okay, I'll be taking that thing later on. So now, first of all, let's see the properties of these charges. So first property is like charges repel each other. First property is like charges repel each other. So if there is positive charge, another positive charge is there nearby, they will repel each other. Similarly, if there is a negative charge and there is a negative charge, they will also repel each other. Okay, this is one of the simplest property which you have studied in the earlier classes as well. Similarly, the opposite of that is unlike charges attract each other, right? Unlike charges. Plus, I would be saying that neutral plus charged body. See, neutral plus charged body, they attract each other. Tell me, do I need to explain this thing? Here I'm saying that repel is the surest thing which could say that the objects are charged. In case of attraction, the attraction could be among the neutral body and the charged body, or the other way around if there are unlike charges. Is this is clear to you? Please do let me know. If not, then also let me know, because I'm going to explain you this thing. Please, I'm reading your chats. Ars, so what chapters will you cover here? Will you cover in depth? I'll be covering everything in depth, and you will got to know how many hours I'll be taking. The video will be for, I would be saying 3 to 3.5 hours it will take. Okay, Gua? Is it clear? Shall we move? Now, moving forward, based on this thing, properties of charges we are doing. Properties of charges we are doing. Next, the third property is charges are additive in nature. Charges are additive in nature. What does it mean? If I'm having a charge Q1 and it's having a value of 2 microcoulomb, and there is another charge which is minus 3 microcoulomb, and if anyone says that you need to calculate Q net, then you can easily add them, Q1 plus Q2, 2 microcoulomb minus of 3 microcoulomb, I'll be getting minus of 1 microcoulomb. So this is the property of that charges are additive in nature, and charges are scalar quantity, so we do not need to concern about it what is the directions. If we just want the net charge, we have to simply add them up. Okay, next, the fourth one is that charge is quantized. This is very, very important, because on this you will be getting some numericals out there in your JEE exam. Okay, so charges are quantized in nature. And if I'm saying that charges are quantized, it means that the charge on a body will only be increased in a fixed term, or on a fixed quantity. Assume that if I'm having a ball and there is a mass of this ball, assume that the mass of this ball is x gram. Okay, if I'm having a two ball similar to this, then the mass of both of them will be 2x, right? I could not have half ball, because half ball is like a bullshit, right? If I'm talking about a half ball, that is bullshit. I could not able to play with the half ball, right? So I'm saying that either I will be having a one ball or having a two ball, or a no ball at all, right? But I could not have 1.5 ball, 2.5 balls. There is not, we do not have the fractional value. So that is what quantization means. So in the quantization, we generally says that the net charge on any body is equals to plus minus n times of the charge on the electron, where this n is the integer. We say that the net charge on a body is equals to the integral multiple of the charge on electron, right? Based on that, we can do one thing. If anybody asks you that how many electrons are there in 1 coulomb of charge, how many electrons are there in 1 coulomb of charge, so what you need to do is Q equals to NE, and if you need to get N, it's Q by E. It's 1 coulomb divided by 1.6 into 10 to the power of minus 19. You will be having 10 to the power of 19. See how I'm solving. 10 to the power of 19, 1.6, right? So I'm having 1.6. What I will do is I'll remove the decimal here and I'll place 10. I'll get 8, 5. Now I'll borrow 0 from here. I'll get 50 divided by 8 into 10 to the power of 18. It's 425. You will get 6.25 multiplied by 10 to the power of 18. So this is what we will get. Now, once you know that in 1 coulomb of charge, we have 6.25 into 10 to the power of 18 number of electrons. It's a huge value, right? If you know that what is the value of Avogadro's number, it's 6.022 into 10 to the power 23, right? You study in chemistry. So similar to that values, we are getting that in 1 coulomb, we have 6.25 into 10 to the power of 18 number of electrons, right? And now, if you know about this, I'm saying that in 1 coulomb, I'm having number of electrons. So number of electron is 6.25 into 10 to the power of 18. If anyone asks you that how many electrons are there in 2 coulomb, so just you need to multiply this thing. 2 into 6.25 into 10 to the power of 18, right? And even see 6.5 coulomb, if somebody asking you, then you need to multiply 6.5 into 6.25 into 10 to the power of 18. But if anyone asks you that can I have a charge of can I have a charge of 0.5 E, or you could say 0.8 into 10 to the power of minus 19 coulomb. That is the question. Can I have a charge of 0.8 into 10 to the power of minus 19 coulomb? To check that, how you are going to proceed. The easiest way to proceed is I am going to calculate that I know that Q equals to NE and N is equals to Q by E. So I'll do one thing. I'll keep this charge as 0.8 multiplied by 10 to the power of minus 19 divided by 1.6, right? 1.6 into 10 to the power of minus 19, because the charge on one electron is 10, this one, 1.6 into 10 to the power minus 19, and you can cut them. This will be cut and you will be finally getting 1 by 2, which is equals to 0.5. And if you are getting a 0.5 value here, then what? It's not an integer, right? It's not an integer. And if I'm not getting an integer here, what does it mean? It means that I could not have this value. So this charge is not possible. This charge is not possible. I hope that this thing is clear to you. Is this thing clear? I joined late. I will start class from starting. Wait, okay, you can do that using, I would say, a 2x speed. Right? Shall we move? Okay. Now, let's find out the number of charges. Let's find out. We got basically while doing the questions of JEE Mains, or even if you are solving your HC Verma book, you have to know that how we are going to calculate the charges in the molecules. So if I am having atom, let me consider a hydrogen atom, or let's say oxygen atom I am taking. So oxygen atom, you can write this as, right, 816. So if somebody asks you that tell me how many number of electrons are there, how many number of protons are there, how many number of electrons are there, and how many number of neutrons out there. See, to find these values, you must know that this is the symbol for the atom. I'm having a Z here and a mass number here. So this is basically a mass number, and here I'm having a atomic number. Okay, so I'm having a atomic number and the mass number. The mass number is basically the sum of protons and neutrons, and the atomic number is actually the number of proton. So to get the, in a neutral condition, if the atom is neutral, the number of proton is basically the number of the atomic number we are having. So here the number of proton we are having is 8. The number of electrons will be same because it's a neutral atom. The number of neutron will be number of neutron. If somebody asks you, so it's A minus Z. So I'll be getting 8. Okay. Now, if somebody is asking you that how much positive charge is there, how much positive charge is there, so you can easily say that positive charge is positive plus 8 multiplied by 1.6 into 10 to the power of minus 19 coulomb. And how many negative charge is there? Minus 8 into 1.6 into 10 to the power of minus 19 coulomb. Okay, so these are the values which you could easily get. And if somebody asking you that what is the total charge here, so let me write this as Q plus and this is as Q minus. So total charge will be Q plus Q minus. Okay, now you will get 0. You will get 0. Now take another example. Let me take sodium, or this is sufficient. I think that this is sufficient that how to get the charge on one atom. So if I'm having a molecule, what if I'm having molecule? Let's say I'm having a water molecule. I'm having a water molecule. There is something which is secret to my student. What is it? I always tell you that you do not have to see the picture, see the pixel. You must have one ability. If you really want to crack any entrance exam, it's not just about the JEE exam, it's about any entrance exam. It's like that once you are undergraduate and once you complete your undergraduate, you have to go for the postgraduate, MS, or any other degree or any other entrance exam. The first thing what you have to keep in your mind when you are preparing for this exam, that The correct strategy will work everywhere. It does not depend that which exam you are giving. So the correct approach is that you do not have to see the picture, you have to see the pixel. What is pixel theory? What I am giving you, what I am projecting you. The pixel theory is that you have the ability, you must have the ability to break the question into multiple parts, and in that part, at least the smallest part, you must be able to solve it. If you're not able to solve it, that means that either you are unprepared or you haven't done your preparation, right? So these are the only things which you could understand from here. So if I need to get the value or the number of electrons in this water molecule, what I have to do is I need to do a multiple things here. I need to break it. How many? If I'll say hydrogen, so hydrogen is 1 1 and oxygen is 8 16, right? So in this you will be having a proton s1, electron s1. In this you will be having proton. Why we are considering neutron? Neutron is not required. Let me rub this neutron. So how many protons are there? Protons are 8, electrons are 8, right? But we know that we have to multiply this by 2. We have to multiply it by 2. Are you getting my point? Why? Because hydrogen atoms are 2 in number. That's why what I'm doing is, if I'm getting 1 electron from 1 hydrogen in water, I'm having 2 hydrogen, so ultimately I'll be having 2 electrons. So in this water molecule, the number of protons we will be having 2 from the 2 protons from the hydrogen and 8 from this, so I'll be having 10 protons and 10 electrons. And if somebody is asking you that what is the positive charge here, what is the total charge here, so you could easily find out. The only thing which you are going to change is the value of this thing. Done. Right? Now, a very simple question from NCERT, which is very important, and I found that multiple times I'm getting a doubt from my students that, sir, I'm not able to solve this question. So please tell me that question, that how we are going to solve the question from that NCERT book, which states that you have to calculate the number of moles, right? There is an NCERT question which says that calculate the number of, or calculate the positive charge. Calculate the positive charge in 1 cup of water. Calculate the positive charge in 1 cup of water. Now, to get the answer, what is the approach we will be using? The approach is very simple, which I have already discussed, that you do not have to see the picture. Picture is that you do not have to see the question which they are asking. You have to divide this question into multiple steps, and those steps must be a doable steps, right? So to get the answer, we must be knowing that what is the quantity in a 1 cup. So here we have to assume a quantity in 1 cup. So let me assume that let 1 cup contains 250 gram of water. So here I am taking that 1 cup contains 250 gram of water. To calculate the positive charge, you must be knowing the number of particles, in 1 cup, right, into the charge. The number of protons is 10. The charge on that thing is 1.6 into 10 to the power of minus 19. I hope that you are getting that what we are doing here. See, for one molecule, one molecule of water, we are having 10 protons, right? And due to that 10 protons, I am having that for one molecule, the positive charge is 10 into 1.6 into 10 to the power of minus 19. So my only concern is to get that how many number of particles are there in one cup. And to get the number of particles, you have to multiply Avogadro's number with the number of mole. With the number of mole. So number of moles is given mass by molar mass. And 6.022 into 10 to the power 23. Given mass, basically this is my given mass because I'm assuming this thing. Molar mass, you can easily calculate that what is the molar mass of H2O. The mass of hydrogen is 1, the mass of oxygen is 16, the molar mass will be 18, right? And this will be, use this, calculate this to get the answer. Okay, calculate and match this answer with your NCERT. You will get. I hope that this approach is clear to you, and the approach is very, very simple. See, you will learn multiple things, but you would not be able to remember these multiple things throughout your life. But there are some approach which I am going to teach you. You will remember those approaches throughout your life, and ultimately these are the approaches that will help you in a long run. Right? You will remember that you have studied physics from Manoj Sir, and if you have studied physics from Manoj Sir, you would not face any issue in your life. That is my promise to you. So I hope that this question is clear to you. Please do let me know. Is this clear to you? The Vardhanash, but sir, water should be neutral na? Yes, water should be neutral, but here what we are doing is, we are just calculating the positive charge. So positive charge is the positive charge value we will get. Similarly, the negative charge value we will get, right? The total charge will be 0. Similar to this, if I am having an oxygen atom, the total charge is 0, right? The total charge is 0, but this oxygen atom contains a positive charge. Also, it contains a negative charge. That is why we are getting the 0. Similarly, if there is a water molecule, a single molecule I am taking, so it is having a positive charge of 10 into 1.6 into 10 to the power minus 19. Similarly, it is having a negative charge, so the total charge is 0. Your total charge is 0. Only ions, right? Only ions like Na plus. If I am considering ions like Na plus, it will be having the positive charge, and if I am considering a chlorine minus, it will be having a negative charge, right? So there will be some imbalance between the positive charges and the negative charges. That is the reason we say that to get a charge body, we must either be losing the electrons or gaining the electrons. I hope that this thing is clear. Gua, your picture trick helped me very much for integration difference. Thank you. I'm able to understand questions with good clarity. Oh, very good, Ved. I hope that this thing is clear, right? This question is very, very important. Like I have seen in my complete teaching career, which is around 1 decade, 10 years of experience I am having, I got this question as a doubt multiple times from the students who are getting 70 out of 70 marks in physics, and a day before the exam they are asking me this question. But I'm not able to solve this question. So I got to know that this is the pain point of every student. Even if he is scoring 70 out of 70 in physics, he got a doubt in this question that how they are doing that, right? But if you have done your HC Verma initially, if you have studied from me from initial days, you will got to know that this is the basic example which I'm taking in my classes, right? I hope that this thing is clear to you, right, guys? Can we do it, sir, without assumptions? See, without assumption you can do, but there are different books. Like I have 8 to 10 books with me, and in those books there is a question similar to that. Like in we have Pradeep refresher book. In that they have taken 200 gram. So at least you have to assume. Why we are assuming that? Because NCERT hasn't provided us the real amount which they are taking, right? So assumption must be there. Either they will give me. Akhilesh, okay, Akhilesh. I will remember your name. Akhilesh was CM of Uttar Pradesh. Okay, shall we move now? Now, see, if there is a matter, if there is a matter, and that matter loses electron, if that matter loses electron, then tell me what will happen. Matter will become positively charged. Right? We will get positive charge. Second one, will will the matter lose weight or will it gain weight? Because ultimately matter is losing the electron, and we know that electron is a matter. So we are losing the mass as well. So the positive charge loss mass as well. Right? And if this matter gain electron, if this matter gains electrons, we will be getting a negative charge. Also, we will be having a higher mass. Okay, and you know what is the mass of electron? The mass of electron is 9.1 into 10 to the power of minus 31 kg. It's very small, but still a significant value. If somebody is asking you that will there be a change in weight or not, then we have to consider that yes, the positive charge will be having a less weight or less mass. I hope that this thing is clear, this point is clear. Now, if this point is clear, let me concise another point. What are the methods of charging? What are the methods of charging? So methods of charging are, there are three methods. There are three methods of charging. Similarly, like if you want to be fit like me, what does fit means? You have to remember this fit. It means that methods of charging are frictional. In this, the method of charging in method of charging, the first method is the frictional method, which is like rubbing an object with another object. If we rub one object with the another object, one object may lose the electron and another may gain the electron. It basically depends upon the electronegativity of the material which we are using or which we are rubbing, right? You must remember that if we rub a glass with a silk, the glass will attain a positive charge. Why glass will attain a positive charge? Because glass is losing some electrons, and silk will attain a positive, silk will attain a negative charge. If I am having a glass rod with me, and there is a silk cloth, and if you are rubbing it together, the glass will be positive charge, glass will get a positive charge, and the silk cloth will get a negative charge. Okay, the second method is induction. I stands for induction. Induction is kind of a influence. Induction is kind of an influence. Like Instagram or on a YouTube, you are getting the influencers who influences you. Ved, what are you saying? That means, sir, at any assumed figure, we'll get the same answer. No, no, no. We will not get the same answer in that case. In that case, if they will be providing you the mass, Like in 1 cup of water, we have assumed that there is a 250 gram of mass. In question, either they will give you 100 gram, 150 gram, because in MCQ, there will be no subjectivity at all, right? So they will be providing you that in what unit you have to get the answer. Like in JEE exam, there is 2 section. In section A, you will be getting the multiple choice questions, right? There you have the options in front of you. Out of those options, you have to choose the correct answer. And by just seeing, by just observing the options, you will able to see that what value you have to take. And in the numerical part, you must be provided with the quantity which or the quantity or the units in which you have to find out the answer. So everything will be given you. Okay, you do not need to take tension for that. The first thing which is required is to get the concept correct, and if the concepts are clear to you, you will be able to solve that question, right? I hope that the that thing is clear. Now I was explaining you that methods of charging. I is the induction method. In the induction method, we use a highly charged object. We use a highly charged object, and if there is a neutral object out there, due to this highly charged object, this is positively charged. So what it will do is the electrons will come at this side, the negative charge will come at this side. There is an accumulation of negative charge, and on the other end there will be a positive charge, right? And if you grounded the opposite side, you will get the negative charge. You will get a negative charge. So using a positive charge, you are actually creating a negative charge, and in this we are not losing any charge. We are not losing any charge from the inducing object. Okay, now the third thing is, this is the inducing object. The third thing is touch, or you can say that conduction. There is a direct touch. Here what we are doing is we are directly touching one sphere to the another. So if this sphere is having a q1 charge, the another one is having a q2 charge, and once they are touching each other, and then you separate them, so after separation, first they touch and then they separate. So the charge on this is q1 plus q2 divided by 2. q1 plus q2 divided by 2. Okay, we will do that if these two charges are symmetric. I'm saying that if both the objects are symmetric, then we are going to use this thing. So please start from Coulomb's law. The next thing is Coulomb's law only. Now, Coulomb's law. Coulomb was basically an engineer who says that if you are having a point object, there are conditions for these Coulomb's law. There are conditions on that. There are conditions on which we can use the Coulomb's law. The first condition that is that they are only applicable on point object. They are only applicable at point charges. Okay, they are only applicable at point charges. The second one is that the charges must be at rest. Charges must be at rest. And the separation between the charges, separation between the charges must be greater than 1 femtometer. Because if the distances between them, if the distances between the charges is less than 1 femtometer, the nuclear force will be dominating, right? And if the nuclear force is dominating, this Coulomb force is very less. Okay, it won't give me the significant value. So if there is a charge q1 and there is a charge q2, they are separated by a distance r. They are separated by a distance r. The force between them is equals to k times q1 q2 divided by r square. You can write it as 1 by 4 pi epsilon naught q1 q2 divided by r square. The value of k is 9 into 10 to the power of 9 Newton meter square per Coulomb square. Okay, now important thing is the epsilon naught is basically the permittivity. It's 8.854 into 10 to the power of minus 12 Coulomb square per Newton meter square. This Coulomb force basically depends upon the medium in which we are keeping the things. So you must be knowing a relative permittivity. You must be knowing a relative permittivity. Epsilon r is equals to epsilon medium, permittivity of medium, divided by permittivity of air. And sometimes we also substitute it by dielectric strength. Dielectric we have to substitute it by dielectric constant. Now, the important factor which we have to keep in our mind is that if the particles is in air, q1 q2 are they are in air, multiple times, most repeated pattern. Most repeated pattern. If we are having two charges q1 and q2 and they are separated by a distance r and we are keeping them in air, the forces between them is F air and it is equivalent to K q1 q2 divided by r square. Okay, and now if I am taking this to another medium where we are keeping it in a dielectric constant small k. See, this k and this k is different. This is there I'm using a capital K, here I'm using a small k. You can use anything. It basically depends upon the question which they are which constant they are using. So if you are keeping in one container, let me I'm taking this container and assume that this container contains some liquid or any other material which is having a dielectric constant K. And if you are keeping here, then your force is reduced to your force is reduced to K Q1 Q2 divided by K R square. Okay, your force is basically reduced by K times, or you can write it as F air divided by K. Okay, these are the two things what you are getting, and using this thing, there are so many times you will be getting that what if these two forces are equal, what must be the distance at this side, or if these forces are being changed by this much of quantity, then what is the value. You'll be getting multiple questions based on this simple pattern. Okay, so sir, I'm from an ST category student. If I start now studying, can I get an IT reply? See, first of all, if you have used Google Map for for getting the exact time to get to the location, you must be knowing that what is your current location and what is your desired location, right? So that is very important. So if you are asking me that, sir, whether you will be able to get the selections or not, then the answer is that yes, but it depends that currently at which level you are. Okay, so Akhilesh got it correct that it basically depends upon that how much hard work you are doing. So I hope that you are doing a very good hard work, isn't it? Shall we move now? Shall we move? Hmm. Chaliye, let's move. The initial case. I'm having two charges Q1 and Q2. I'm having two charges Q1 and Q2. They are separated by a distance R and the force between them is F. We are having two charges Q1 and Q2. They are separated by a distance R and the force between them is F. What if I'm taking them what if I'm taking them what must be calculate the distance if I want the force to be 2F. Okay, Calculate the distance between the charges. If the new force is 2F. So that is the question. Very easy. Very easy question. Now tell me, what could be the answer? Tell me, what could be the answer? I hope that this question is very easy for you, all of you guys, right? Actually, it's not about the question. It's about that what is your approach to get the answer, and your approach must be the approach which I am telling you. I hope that this thing is clear. You know what? When you are studying from any teacher, what does that teacher gives you? Teacher gives you the confidence of solving the question. Teacher gives you the approach of starting the question. Any other thing you have to attain on your own. Are you able to get it? Akhilesh, please let me know. Are you able to get it? Are you able to get the correct answer? See, the question is very, very simple. If from here I'm getting that F is equals to K Q1 Q2 divided by R square. Here I'm getting 2F is equals to K Q1 Q2 divided by R dash square. This is my equation 1, this is my equation 2. If you substitute it, you will get 2K Q1 Q2 K Q1 Q2 divided by R dash square. So here you can cut this K Q1 Q2 K Q1 Q2 and R dash will become R divided by root 2. So that is 0.707 R. That is the value which must be your answer. Okay. I hope that this thing is clear. See, first you have to do what is necessary. Somebody was asking me, sir, what must be my correct approach when we are in last 15 days of December and 2025 is going to start. First, basically, you have to do what is necessary, then do what is possible. And before you know it, you are actually doing what is impossible. Right? So first do what is necessary, then do what is possible, and before you realize, you will be doing the impossible thing in your January attempt. So these are the things what I'm telling you. Shall we start now? Yes. Now, now I'm drawing one question for you. Let me assume that there are two masses m1 and m2, and the charges on them is q1 and q2. Okay, and they are having both are having same length. Okay. Here the angle is alpha, beta. Alpha and beta are basically the angles made from the vertical. Here also I am having an angle alpha and beta. So there are some conditions which I am going to tell you. You have to tell me the correct answer, that what must be the relationship between the alpha and beta if the condition is here, the condition is m1 equals to m2, q1 is equals to q2. Okay. Then find the relation between alpha and beta. Find the relation between alpha and beta. So alpha will be equals to beta, alpha is greater than beta, alpha is less than beta, none of these. Now you tell me that what is the relationship. You tell me that what is the relationship between this thing. Let's start it from the first case. This is the case 1, case 2, case 3. Now let me know, according to this condition, when the masses are same, the charges are same, you have to tell me that what is the basic relationship between the alpha and beta, and these are the angles made from the vertical. You let me know. Akhilesh, tell me what must be the relationship between them. I think that it's very simple question. You just need to apply your brain. Fine. Tell me. Question is in front of you. See, when both these m1 and m2 are equal, q1 and q2 are equal, we are getting the angle must also be equal, right? Actually, the difficulty starts from here. What if q1 is greater than q2, but masses are same? So I need to understand that how basically I have marked this question. So I know that if somebody is having the mass, there will be some gravitational force. So gravitational force acting on this is m1g. The gravitational force acting on this is m2g. And from the question, I know that m1 is equals to m2. That means the gravitational forces acting on both the masses will be same. The gravitational forces on both the masses will be same, right? Are you getting that point? And here I know that due to this charge, if I am considering that this is positive charge and this is positive charge, if both of them are positive charge, then they will be repelling each other, right? The force on this charge will be F is equals to, I'm considering the distance between them is R, so that force is equals to K Q1 Q2 divided by R square, and the force here is equals to K Q1 Q2 by R square. Can you say that the force on one and the force on two are same? Actually, the Coulomb force is basically the multiplication of both the charges Q1 and Q2. So it doesn't matter that what is the value of the Q1 or what is the value of the Q2. It's basically the value of Q1 product Q2 or Q1 multiplied by Q2 is what we have to see. So here the force 1 and the force 2 are also same. So if both these forces are same, then you know that these angles must be same. So here also I am getting that alpha is equals to beta. Alpha is equals to beta. Now the question arises that what will happen if I am getting one gravitational force more as compared to the other, right? So now we know that if the body is having a mass, there will be a gravitational force. So on this object I am getting a gravitational force as m1g, and on this I'll be getting a m2g, right? Similarly, here you will be getting a force F1 and F2, and from the previous question I know that these electrostatic forces F1 and F2 must be the same, right? These must be the same. The difference is that now this time m1 is greater than m2, and I am using my approach. What is my approach? That if I do not have any plan, see, remember this approach. This approach is very, very important because I'm going to use this approach multiple times throughout when I'm solving the questions from the real exam paper. And in this session, I have included the question from JEE 2024 previous year, right? So what is my approach? My approach is that if I'm not having any plan, and exactly this is my plan, that if you do not have any plan, search for the extreme end. You have to search for the extreme end. If in the question there is m1 is greater than m2, I'll be considering m1 is as heavy as I could imagine, right? I will be considering m1 as heavy as I could imagine. So if this object is very, very heavy, it will not move from this point, right? It will not move from this point. The alpha will be very, very less. And if this object is very light, this will be moving. Assume that I am having a ball with me, a balloon, and I am blowing air on that balloon. The balloon will go away, I will not. But according to the third law of motion, even I am getting some force, right? So here I could say that if m1 is more, then the alpha will be less. So my answer will be third option in this. I hope that you got the correct explanation. Is it clear, my dear Akhilesh? See, the approach must be very simple. First you have to do what is possible, right? I hope that this question is clear to you. Now let's work on another question, that how we are going to apply the free body diagram on the situation like this. If I am having two strings, there are two masses m1 m2, length L and L. Now as I told you that the distance between them the charge on this is Q1, the charge on this is Q2. Positive charge here, positive charge here. Okay. Now I know that once the object is having mass, the direction of force due to gravity is fixed, that is downward. So here the gravitational force is acting downward, and the value of this is m2g. And I also know that due to these positive charges, there will be an repulsion force out there, and the value of this is k q1 q2 divided by the r square, right? So there are two forces which is acting on it. If we have connected these two masses with a string, then I am also having a tension out there. And let me consider that there is an angle alpha. You can use that alpha here, right? If this is alpha here, also you'll be getting alpha here, right? So this tension, if you resolve it here, you'll be getting t cos alpha, and if you resolve here, you'll be getting t sin alpha. And if there is equilibrium, you could get, C in terms of x-axis and y-axis. Whenever you are solving the questions related to the forces, you have to see in terms of the x-axis and the y-axis. This is the approach which we have to use. And if you have attended my lecture from Newton's laws of motion, that was the approach I have taught you, right? You have to see in terms of the Cartesian plane, and the Cartesian plane is like x-axis and y-axis. I hope that you all are familiar with this x-axis and y-axis. This is x dash, this is y dash. And I'll only be relating all the scenario which you have already know. So I'll be using that in x-axis. So if I'll be considering that there is an equilibrium in the x-axis, so I can compare that this t sin alpha is equals to the electrostatic force which I am getting, and this t sin for I'm considering this one, and for the y-axis, I am getting t cos alpha is equals to m2g. And if you divide this 1 and 2, you will be getting tan alpha is equals to Fe divided by m2g. Right? This is very, very important formula. Sometimes you have to substitute the value of Fe. Sometimes they have asked the value of R, even R as well. And here I am taking this in a different terms. Let me assume that this is the theta which is important for us, and this is the tension force which is acting on this. Due to this tension force, I can resolve this tension force towards this. I'll be getting t cos theta, and if I'll go above this, that will be t sin theta, right? And this is m1g. Again, there also I'm having an electrostatic force. So for x-axis, I'll be having that t this time. This time there is a difference, right? So let me start with y-axis this time, because this time in y-axis I am getting sine. So t sin theta is equals to m1g. I am considering this as equation 1. And if you are considering x-axis, see, I'm always, whenever I am dealing with the questions related to the forces, I always prefer to see in the terms of axis and see that how I can compare one force with the another force. This is the only approach which you are going to use. And if you are using this approach, you will be able to solve questions very fast. Somebody was asking me, sir, why you are telling me that this is the perfect approach and we could not do with another approach? Why I'm telling you? See, from my decades of experience, I'm sharing you that I have studied or I have analyzed multiple approaches, and these are the simplest approach that you can use to initiate the question. If you are getting your answer with your approach fast, you can go with that, right? So let's see. This is the x-axis, and for the x-axis, you could do 2 cos theta is equals to Fe. So this is my second value. So if you divide them, you will get tan theta is equals to m1g divided by Fe, right? So this, you must remember that it basically depends upon that from where we are taking the angle. You do not have to remember these formulas. You have to know that what must be our approach, and our approach is very simple, that we do not need to see the picture, we have to see the pixels, right? The picture could be different for everyone, but pixels will be same for any question. So what I'm doing here is I'm not looking at the picture of the question. I'm dividing the data from the question into the pixels. What is the pixel here? Pixel is the data in the x-axis and the data in the y-axis. What is important for me? I hope that this approach is clear to you. Is this thing clear? Right? This is what is necessary. You must remember that how we are going to use this thing. Shall we move? Shall we move? Please let me know. I hope that this approach is clear. Now we can move forward. The next approach is superposition. Superposition when there are multiple charges. When there are multiple charges, so the force which you need to calculate will be actually the individual forces, the sum of individual forces okay, you need to add them up. And there is a fixed pattern which you will be getting again and again, irrespective of the exam for which you are preparing. You will see that if you know that how we are going to use this approach, you will be able to solve these types of questions. These types of questions will repeat not only in this Coulomb's force topic, but also in your electric field, also in your electric potential, and later on when we study the magnetic chapter. So these are very, very important patterns that you must know, that these are the only types of questions that you will get in your exams. So you must be well prepared with these concepts. Shall I start? So the pattern is important pattern. Okay, there could be a triangle, and in this triangle you are having three charges, q1, q2, q3. Let me consider that all these charges are positive in nature, and you need to find out the net electric force either on any of the charges or at center of the charges, that is centroid. Or at any other midpoints at the centroid also. See that I'm having another charge q. Okay, now I'm taking it separately. First of all, understand the approach which I'm going to use, because that approach is very, very important. So here my approach is RIN. My approach is RIN method I'm going to use. And what is this RIN method? This RIN method stands for, R stands for that you have to reach on the spot where you need to calculate the force, electric field, potential, or later on we will be finding some other things. First of all, you have to find the at the location where you want to calculate the things. So if I need to find out the net force at this F1, this Q1, let me mark these points as A, B, and C, and let me say that I have to find out the net force at this point. Okay, now I'm seeing that this is X distance, Y distance, Z distance. Okay, now here I'll reach at this point. Okay, now you will say, sir, what, sir, after that? I'll reach, sir, I can go anywhere. Newton told that, Newton not, Einstein. Einstein says that logic can take you from A to Z, but imagination can take you anywhere. If you want to go anywhere, you must be having a very good imagination. There was a joke in my class earlier. One student was there, and he was making a fun of his friend, and he was telling that, sir, do you know that this Divyansh is having a girlfriend? I asked Divyansh that, Divyansh, are you having a girlfriend? He denied that, no, sir, I do not have the girlfriend. Then again that boy says, no, sir, he is having the girlfriend, but and even that girlfriend is not from this nation. Huh? I asked him that, oh, you either like I was in a feeling that either he's having a girlfriend from the internet, or he might be like have some friends with whom he's talking. So I asked him that, Divyansh, are you having a girlfriend again? Then he told me, no, sir, I do not have the girlfriend. Then again that boy says, sir, he is having the girlfriend in imagination, a different nation, imagination. Every every classmate of him like laugh, LOL, right? Laugh out loud. So it was like that. But you know that imagination is the greatest power what you can own, and using the imagination you can go anywhere, right? Even in your imagination you can be Pushpa, you can be Rocky Bhai, or you can be anything. So the first thing what you have to do here while solving the question, the imagination, correct imagination, is that once you have to initiate the question, you have to reach there where we have to calculate the force. So we must be reaching at a point where we need to find out the force. The second thing is I. The I stands for, I look for the individual data. I look for the individual data. What does individual data means? Individual data means that I need to calculate the force, electric field, potential, whatever I need to get. And when I'm asking you that you have to find out the individual data, it means that if that quantity is a scalar quantity, only magnitude is required. But if that quantity is a vector quantity, magnitude plus direction, both of them are required. So here I am saying that you must be getting the magnitude plus the direction if that quantity is a vector quantity. So what I need to do is, I am standing here, and if I am standing here, I need to be more selfish, and I'm only concerned about this point, that at this point how many charges are applying the force. So at this point I am getting the force being acted from this B and C. You know what, there is an old saying which says that you can't be jealous from yourself, right? Jealousy only can be created from the other person. So it's like this point will not get any force due to that point only. The force must be acting from the other points, like the force, if this is positive charge, this is positive charge, I'll be getting a force from B, right? I'll be getting a force from B, and that force from B is in this direction. I hope that you are getting. There will be a repulsion, and you can mark this, that the force is K, Q1 Q2 divided by the distance between Q1 and Q2 is x square. I hope that this data is clear, that how I'm going to find out the individual data. So I'm getting the individual data, that at this point the force due to this is FB, and the force due to this Q3 at this point will be in this direction, and that force will be FC is equals to K Q1 Q3 divided by Z square. Okay, that is the force. Now these are the individual data which you could find out, because there are only 3 charges, and due to these 3 charges on this, only 2 charges can apply the force, right? So I got the data which I want, and the direction is also mentioned in the question. Now the third thing is, you need to find out the net force. You need to find out the net force, and net force is basically the vector sum. And if I need to get the vector sum of this, so F net, let me assume that the angle between them is theta, so the net force is F1 square F2 square plus 2 F1 F2 cos theta. I hope that this thing is clear to you. This is a very important pattern, and similarly this pattern is important, but more than this pattern, this approach is very, very important. This is my unique approach. You will not find this approach anywhere, and if you are getting this approach, either he or she will be a student of mine, or they have copied it from me, right? So because this is a unique approach, because I have learned this approach from my mind, right? Nobody have taught me. I have not gained it from anywhere else. This is my own invention, which I have done for my students. And using this approach, I know that even the average student or a below average student are able to solve the questions from the electrostatic chapter. So this is my power. You know what is my power? My power is to transform the below average student into the average and the higher ranking students. So that is my power. Let's move towards this part. This is the second approach. The second is, if I'm having a charge here at Q, and if I need to find out that what is the value of net force at this point. So to get the net force at this point, first of all, I need the distance. Right? I'm not considering that this is an equilateral triangle. I'm considering that the distance from this is x, the distance from this is y, and the distance from this is z. Okay. Now, if this is my G point, if this is my G point, I'm considering here the G point. The force due to this A point will act in the downward direction, right? The force due to this will act here, and the force due to this will act here. These are the forces which you will get. You have to find out the angles, and then again you have to do the net force. Okay, but remember that whenever we have to calculate the net force, we have to do the vector sum, right? So this is a very, very important approach that you have to keep in your mind. Is it clear, Akhilesh? Is this thing fine? Shall we move towards the another point? Okay, let's move towards the electric field. See, there are two types of forces. The first type of force is a force in which we have to apply the contact, or using the contact only, the force could be transferred from one object to the another object. Or the another type of force is the non-contact force. In non-contact force, we do not require the actual connection or the actual touch from one object to the another object to transfer the force. There we require another quantity, which is the field. So here I'm saying that if there is a charge, let me draw a table. Let me draw a table here. Take a deep breath and be active. If I'm having a table here, and on this table I'm having a charge Q. You know what? If I'm having a charge here and that charge is at rest, even if this charge is at rest, it is creating something. It's like you are having a perfume bottle with you, and you are spraying it. If you have sprayed a perfume from your perfume bottle, then there will be a smell, right? And that smell would have some area. Till then, till at what distance you could smell that there is a perfume smell. So I'm saying that if this charge is at rest, then due to this charge, in area around it, we can experience a force if another charge enters in this region. If another charge enters in this region, then this charge will experience a force. So for experiencing the force, we require two things. The first one is the charge itself, and the another thing is the field. So to get the electric field, you can get limit. Here we are considering the charge to be very, very small. We are getting electric field is equals to force divided by Q. Okay, and the force is KQQ divided by R square. So electric field will be equals to KQ So force will be kq divided by r square. This is the value of force which we are getting. I hope that this formula is clear to you. This formula is very, very important, and similar type of questions you will be getting, the types of questions which we were doing earlier, right? I hope that this thing is clear. There are different scenarios in which we have to find out the electric field. Let me take a very simple question. What if I'm having a square, and in this square all the charges are having q charge. Three of them are having q charge, and at this point I'm not having any charge. Okay, at A I'm having a charge, at B I'm having a charge, at C I do not have any charge, at D I do have one charge, and all of these charges are positive charge. So you need to find out the electric field. This square is having a length as A. You need to find out the net electric field. Net electric field at C. This is the question. The approach will be same what we have learned earlier. The approach will remain same. The approach is RIN approach. This is a unique approach from your Manoj Sir. Remember that this is a unique approach from your Manoj Sir. The approach is RIN method. In this RIN method, you have to think in 3 steps. First step is that you have to reach the location at which you have to find out the force, electric field, potential, and even the magnetic forces. We will see that. You have to reach there. Second one is that you have to find out the individual data at that location. What is individual data? Individual data is that you have to use the force or the electric field or the potential formula, and you have to write that. It could be that that value is a scalar value or a vector value. If that value is a scalar value, you do not need to consider the direction. Okay, but if that value is a vector quantity, you have to consider the direction as well. And once you are done with the individual data, what you need to do is you have to calculate the net. You can get the net value by just getting the vector addition or the scalar addition. It depends upon the quantity which you are solving, right? So let me calculate the electric field. Now I know that how to decrease the size. Can I change again it? Very good. So now find out. Find the electric field. Our approach will remain same, right? My approach will remain same. That is my approach. RIN method. See, if you are in class 12, you will forget every formula once you pass out your class 12. But these approaches will remain with you even I can say like if you are in a job or even if you debt, you will have this approach that Manoj Sir taught you, a RIN approach, and you will remember this. You will remember me for your lifetime. The limit not understood. Limit is basically we have to Ragul, the class duration will be around 3 to 3.5 hours. I'll be keeping that because I want the class to be very concise, so that even that you, if you have to revise, you can have you will have some time to revise the questions, right? So I'll try to wind up everything in 3 to 3.5 hours. Limit is basically we are keeping here the limit basically we are keeping that the test charge is very small. By default, if question is not saying anything, by default, we will be taking test charge as a positive and charge and mass are very small. Okay, Ved, I hope that this is now clear. Is it clear? I hope that this thing is clear now. Do let me know. I hope that this is clear now. Now, let's see. I'm having a very simple approach, very simple approach. And if you follow this approach, you can solve the toughest question. I can bet on that. You can solve the toughest question from your JEE exam. So the approach is, first you have to reach the location at which you have to find out. So my location is here. My location is this point. Okay. And if this is my location, at this point, I need to find out the individual data, and individual data is the electric field value. The formula is written here that the value is kq square kq divided by r square. I know that due to this A, I will be getting the electric field A, and the value of this is k q divided by the distance is, this value will be root 2a, right? So you'll be getting 2a square. How many of you are getting? Because I need to square this term, right? Now, at this point, you will also be getting EB. That EB is equals to KQ divided by A square. Now also, you will be getting EC. That will be KQ divided by A square. And I told you that these are the individual data which we are getting. First step was to reach at the location. So I reached the location. The second one is to get the individual data. So if I'm standing here at this location, the electric field will be due to these three charges, right? So due to these three charges, I am getting that what are the individual values. So I am getting EA, EB, EC here. And now what I need to do is I need to get that what is the net force here. So to get the net force or net electric field, E net, I need to solve it. I believe, I am a staunch believer that you do not have to show your heroic in solving these types of questions when you are having three vectors. First solve two vectors and then add them up. So I'll be going to solve first these two vectors. Okay, so if you solve these two vectors, as these two vectors are in the same direction, like they are perpendicular to each other, so you'll be getting EBC is equals to under root EB square plus EC square, right? The angle between them is 90 degrees, so plus 2 cos theta will become 0. So I'll be having EB square plus EC square. You can write KQ divided by A square this you will get, right? And finally you will be getting root 2 KQ A square. This is the value of EBC. This is the value of EBC. And finally, you need to find out E net, and the value of E net is EA plus EBC, as they are in the same direction. So we do not have to do anything, just simple addition will work. So you will be having KQ divided by root 2. Okay. I hope that this thing is clear. Now further, if you want to calculate, you can do it. Like you can take the common KQ by A square could be taken common, and you can replace all these values. It depends upon the options which you are having. Okay, I hope that this pattern is clear. Sir, 2026 Rathai Kamal. For JEE 2026, I'll be taking a separate session. In that, I'll start from a very basic things. So I'm going to take, going to start it from part 2. Okay. If you all agree with me, I'll be starting it from part 2. I hope that this thing is clear. Is it clear, my dear? Shall we move? Shall we move? Yes. Now, other than that, we have to know another simple, a very simple term, which is known as electric dipole. You know what? Scientists are so good observer that whatever they find out, they give a special name to that thing. So electric dipole is basically an arrangement. We are just giving it a fancy word, that electric dipole. What does dipole means? Di means two and pole means polarity. Polarity means that these two things are very far away, that you could not imagine that there is any similarity. Just like male and female, they are two separate poles. The another thing is positive and negative, two separate poles. North pole and south pole, two separate poles, right? So these are the two things which are separated. So here we are having two charges separated by a very small distance. So electric dipole is basically an arrangement. This is basically an arrangement in which two equal and opposite charges are separated by a small distance. Okay, electric dipole is basically an arrangement in which two equal and opposite charges are separated by a small distance. You could consider this thing as negative, positive. Remember how I am creating this thing? I am deliberately keeping the negative charge in the left hand side because the direction of the dipole moment in the electric dipole is from negative to positive charge. So this is how you could remember that there is a situation in which we have to take the direction as well. So I am taking a negative charge here. So the charge on this is minus q, the charge on this is plus q, and they are separated by a very small distance. See, the distance between them is very small, but still we have to consider, we have to do the calculation, right? So I am considering that distance equals to 2a, because for any calculation I'm going to take it from the center point of the dipole. So the center point of the dipole is here and that point is O. Every calculation for my numericals will be from this point. Okay, remember this thing. And also there is another term. This is basically an arrangement out there, that two equal opposite charges separated by a very small distance, and I'm considering these distance as 2a, right? And O is basically the center point. O is basically the center point of this dipole, And we have another term which is known as dipole moment. The symbol for this dipole moment is P, and you can do the calculation by taking any charge and multiplying it by the distance between the two charges. So I'm considering the distance between the two charges as 2a, so I'll be doing it q dot 2a. The direction, as this is a dipole moment is a vector quantity, so we are also having a direction. So the direction of this is from negative to positive. Negative to positive. Okay, that is the direction of the dipole moment. I hope that this thing is clear to you. And now we have to find out the electric field. We have to calculate the electric field due to this dipole. There are three patterns in which you have to know that how we are going to get the electric dipole moment. But as I am teaching you for the first time, I am also teaching you that what could be your approach if you forgot the formula in the exam, because this is going to be a very important concept, and I have seen that in the previous year questions you will be finding that based on this topic there are so many multiple questions you are getting again and again in every shift of the paper. But still, if you forgot, you cannot take the risk. You must be knowing that what is the steps for the derivation. That's why I'm going to teach you the derivation, as well as somebody maybe some of you might also be preparing for the board exam. There also you require the derivation. So let me go for the derivation. First of all, I'll make you understand that at what location, at what point we need to find out the electric field. Okay, so if I'm considering this thing, this is my negative charge, this is my positive charge, and I'm considering axis here. Okay, if I'm considering an axis here, this is my north pole, this is my south pole, and this is my equator. This is my north pole, this is my south pole, and I'm having an equator out there, right? So this north pole and south pole, the line joining the north pole and the south pole is known as axis, right? This is basically the axis. So here also, if you are joining the poles, if you are joining the negative charge and the positive charge, this axis is known as axial line. This is basically the axis, and if I'm considering the line, this is known as axial line. And if you are considering a perpendicular out there, a perpendicular which is lying, going through the center, this line is known as equatorial line. Okay, and anything between them, the equator and the axis, is the general point. So we have to know the electric field at the axial line as well as the equatorial line, and as well as in the general line, general point, right? I hope that this thing is clear. So do you know Tamil? Little bit. Like I can understand Tamil, but it's not like I'm not fluent in that, because I'm staying in Delhi. Even I can understand like multiple languages. I can understand Malayalam, I can understand Tamil, I can understand Telugu, right? I can understand Kannada. So there are so many languages which I know. Even like I'm very fond of the Bengali as well. I can understand it what they are saying. And if you haven't subscribed our YouTube channel, please subscribe. And if you haven't hit the like button, please hit that like button as well. Marathi. Kuthe basla? I have been to Mumbai for around 2 years, and in that 2 years I learn only few sentences to survive there. to purchase some fishes from the fisherman and the and to get the discount in the autos. Ved, are you from Maharashtra? Huh? Are you from Maharashtra? Let's let's get the electric field. Electric field due to an electric dipole. The first condition which we are taking is that axial line. At axial line we have to calculate that what is the electric field. So if I'll reach there, if I'll reach there, from this center, the distance to this point is r. And I need to find out the electric field at point P. I need to find out the electric field at point P. Electric field at point P due to an electric dipole. This is the question which we are having. And to get the answer, see, I can give you the direct formula, and even if you know the direct formula and the concept, you will be able to solve the question. But the problem is, I have seen that multiple times a student faces an issue to remember the formula. And you can easily find out the formula within few seconds in your real exam if you know the correct approach. And if you know the correct approach, you will be able to solve the other types of questions as well. Because in these types of derivations, basically derivations are nothing but just you can say that it's also a type of question in your physics. So basically it tells you that what is the real reason behind that formula and how we can derive or get to that formula, right? So shall we move? You are from Maharashtra, Ved. Okay, very good. In like Maharashtra, from which city? Which city? Where are you from? Now. Okay. At this point, my approach will remain same. As I told you, my approach will be, my approach is RIN approach. I'm going to use the RIN method. And what does RIN method says? RIN method said that you have to reach. Second one says that you have to calculate the individual data, right? You have to calculate the individual data. And the third one is, it is saying that you have to calculate the net data. Right? These are three simple steps which we will be following again and again. So here also we will be doing the same thing. So I reached at this point, and at this point, if I'm looking for the individual data, I would be getting that at this point the electric field will be due to the positive charge, and due to the positive charge the electric field will be moving away from this point, and there will be the electric field due to this negative charge, and for from the negative charge the electric field will be going in this direction. What is the value of E plus here? So the electric field due to the positive charge will be K Q divided by the distance from here to here. See, the distance from here to here is R. So distance from here to here is r minus a, because the distance from here to here is a, and this is also a. So this is r minus a. Okay, so I can say that E plus kq r minus a whole square, E minus kq r plus a whole square. Say E minus charge is here. The distance from P point to this point is r plus a, right? I hope that point is clear. At any point, we are going to measure the distance from the center of the dipole. This is very simple approach, right? So the value of this is this much. And now we know that electric field is minus here. Or even if you are not considering the minus sign, we will get the minus sign from here. That if I need to find out the E net at P point, so E net at P point will be equals to E plus minus of E minus. Because this positive electric field is going in this direction and the negative field is going in this direction. And if they are going in opposite direction, I can get the net effect only if I subtract the first equation, right, from the second equation. Isn't it? Ved, Vardarshan, Ratai Kamal, Akhilesh. Is this point clear, my dear? Now, if that point is clear, you could do one thing. Substitute it. KQ. I can consider, you can take KQ as common. You'll be getting r minus a whole square minus of r plus a whole square. Okay. Now you will be getting KQ r square minus a square to the whole square. Why? Because this is a plus b, a minus b. A plus b, a minus b is a square minus b square. And we are also having this square also. So I'll be getting this value. And if you open this, you'll be getting r square plus a square plus 2ar minus of r square plus a square, okay, r square plus a square minus of 2ar. Okay, now E net at P will be equals to, I need to open this bracket. If I'll open this bracket, this will become minus minus and this side will become plus. And you will be getting this r, this will be cut. You'll be getting 4ar. Right? And you can substitute it with 2kpr divided by r square minus a square to the whole square. So this is the formula which we are getting. Let me create some space here. Let's consider this thing as well. Okay, now I have to take a special case as well. For a special case, or if I am getting E net at P, you can get 2 kpr divided by r square minus of a square net at P is equals to 2 kpr divided by r square minus of a square to the whole square. Okay. Now for the special case, this is the formula which you must remember. And for a special case, what you need to do is you have to take that if r is greater than a, if this r is very far away from the dipole, then you have to take only r. It will become r to the power 4, and the formula for this condition is E axial is equals to 2 kp divided by r cube. 2 kp divided by r cube. I hope that this derivation is clear to you. Ved, is this thing clear? Please do let me know. Is this derivation clear to you? Okay. Now, if this derivation is clear, there is a similar type of derivation for the equatorial line. Why I am telling you the derivation, even if you are preparing for the JEE exam, it's because if you see an example in NCERT, you will find a similar type of example is there. In that example, they are giving you the numerical, right? They are not asking you that due to the dipole you have to find out it. In that question, you will be provided with the positive charge, negative charge, and you have to find out the electric field at the left side of the corner, at the top side of the corner. So there is an NCERT example, and if you see the recent pattern from the NTA, you will find that the direct questions are coming from the NCERT. Even they are not changing the values. So you must remember that how we are going to solve that thing, right? Now let's move towards another thing, and here we have to find out the electric field due to a dipole. Electric field due to an electric dipole. That we need to find out. Okay, now at equatorial line. So consider the same diagram. I'm having a positive charge, negative charge, separated by a very small distance. Okay. Now at a distance from this point O, from the center, this charge is minus Q. This charge is plus Q. And you need to find out the electric field at this point. My approach will remain same, right? See, why I am telling you the derivation, because approach is very important. My approach will remain same. Even when we are solving the numerical here, my approach was that you have to use the RIN method. In that RIN method, first of all, you need to reach at the location where you need to find out the electric field, the force, anywhere, right? This is the approach. The second thing is that you have to find out the individual data, that at that point, what are the other charges which is providing the force. Second one, providing the force or the electric field. The next one is to get the net effect, right? So this is the method or the approach which we are going to use. I'm not going to change my approach in any question. That is my strength. That is my way of teaching you. That is why I am having a track record that my student never faces issue to start a question. They can start the question even for the Olympiad, right? And if they have done a very good practice, they will be able to crack it. So here I could get a net field. Here I can get a net field. To get it, at first of all, I need to reach, because here I need to get the electric field value. So I'm assuming a small person standing at point P. Due to this positive charge, the electric field direction at that point will be in this direction, right? You could write that this is E plus. Due to this negative charge at this point, I'm having E minus. Okay, now so this is my E plus, this is my E minus. So if you calculate E plus, that E plus will be equals to KQ divided by, now this is R, this is A, the value of this is R square plus A square, right? And I can say that this is L. You have to consider that distance. So that distance is equals to R square plus A square. Okay, I'm writing it R square plus A square. Similarly, for E minus, you are having KQ divided by R square plus A square. This is your part 2. And to get the net value, what you can do is, if the angle here is theta, I will get theta here, I will get theta here, right? If I'm considering that this is the angle at which I'm having a point P from the negative part, so there will be an angle theta, and there also I'll be getting an angle theta. If I'll resolve this E plus in this direction, I'll be getting E plus cos theta. If I'll resolve this value here, I will be getting E minus cos theta, right? Similarly, if you resolve this vector here at this point, you will be getting E plus sin theta, and at this point you will be getting E minus sin theta. As you know that E plus and E minus are having the same magnitude, and if they are having a same magnitude, then you could say that if both of them are having the same magnitude, you could say that this E plus sin theta will cancel out this E minus sin theta. And ultimately, if you need to find out the E net, that E net is actually the sum of E plus cos theta plus E minus cos theta, and when both of them are having the same magnitude, you could write it as E plus cos theta. Then replace the values, 2kq r square plus a square, and the value of cos theta here is, cos theta is base divided by hypotenuse, so I'll be having a divided by r square plus a square power 1 by 2. So I'll get E net is equals to kp r square plus a square power 3 by 2. So this is a very important formula which you have to remember. And even for this we have a special case. Just like we have a special case in this, we got a special case in that condition as well. So I am just copying it using the technology, that if I am having a special case, for a special case I'll be taking that r is greater than a, that you are going very far away from the midpoint. Then at that point you will be only considering this r square multiplied by 3 by 2, you'll be getting cube. So equatorial your e equatorial will become kp divided by r cube. So this is the formula which you will get. I hope that you are getting this. Is this thing clear, my dear? Right? This is the quickest way to get it. Now I'm going to concise it because that is what you need to know. That if I know the electric field due to an electric dipole at the axial point and at the equatorial point, and you know the derivation is very important. Why I am doing the derivation is to give you a hint, to give you the approach which you could use in the exam, because I must be very confident that you know this approach when you are solving the question. Rin method. I hope that now you can apply the Rin method, right? Akhilesh, are you now confident with the Rin method? Equilibrium in what condition? Equilibrium in what condition? Like to get the equilibrium, see, when you are saying the equilibrium in what? Equilibrium in the forces, equilibrium in the electric field, or the equilibrium when we are keeping this electric dipole in the electric field and this dipole is moving. Equilibrium in what condition? There are so many conditions, right? It depends at what condition you want me to do that thing. Now, electric dipole. This is negative Q, this is positive Q. I'm having a center O. At a distance, let me consider this point as A. If I need to find out the electric field at A, this is A. So that is what we have done in the previous question. The value will be Kp, R square plus A square, value goes to 3 by 2, right? Kp, R square plus A square, the value will be 3 by 2. Similarly, if you are at R distance at this point B, the value of EB is equals to, we have copied it, right? It's 2 kpr divided by r square minus a square. This will be my answer. Now for a special case also, you need to remember, for a special case, when r is greater than a, you can write this as EB is equals to 2 kp divided by r cube. And for similarly for this, at a special case, for a special case, for a special case, R is greater than A, you will be having EA is equals to Kp by R cube. Okay, now another thing. If I am using a general equation at an angle theta, I am at this point P. Then at this point P, this is a general point. It's not a equatorial point, not an you will be saying an actual point. It's a general point. So at this general point, I'll be having the electric field as Kp divided by R cube 3 cos square theta plus 1. Okay, for the axial line, theta is equals to 0 degree. And if you place the theta is equals to 0 degree, you will get 4 value. So you will be getting 2 Kp divided by R cube. And for the equatorial line, theta is equals to 90 degree. Okay, so these are the values which you must remember. I hope that this thing is clear to you. Is this thing clear? Forces. Okay, for forces you have to, like we have already done for the equilibrium, you just need to, I have given you the approach that in case of forces equilibrium, you need to think in terms of the axis, that you have to just compare the force of the x-axis with the y-axis, right? Just compare the force of the x-axis and the sum of the forces in the x-axis must be equal to 0. Or you could say that the force which is going towards the left hand side must be equal to the right hand side. And in case of y-axis, the force which is going upward must be equal to the force which is going downward. So these are the terms which you have to remember. I hope that these are clear to you. This method is clear. Wait a minute. I'll put my laptop on a charger. Guys, do share this session with your friend, because these sessions are going to be very, very important. And now we are moving towards the most important. Thing which you have to remember. Shall we? Shall we move? Now, shall we move? Alright, tell me. Okay. Now, similarly, there could be a question. If there is a ring, of radius r and at a distance x, you need to find out that what is the value of electric field at this point. Can you? Charge on this, the charge on this ring is Q. Charge on this ring is Q. Okay. Now, if you need to find out the electric field at this point, That will be equals to kqx divided by r square plus x square to the power 3 by 2. Remember this formula? This formula is very, very important. This formula is very, 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 very important, right? And if you have to calculate the value of electric field at the center, now tell me, electric field at the center is equals to 0. Why? Because if you put x is equals to 0, if you put x is equals to 0, if this person is moving closer and closer to the center, what does it mean? It means that your x is decreasing, and at the center, this x will be having a 0 value. And if this x is 0, I'll be getting my electric field as 0. Isn't it? Tell me. Ved, I hope that this thing is clear, right? Right? Let's move. Now, the next topic is electric flux. So, electric flux is basically the number of electric field lines passing through a particular area. Electric flux is particularly the number of electric field lines passing through a particular area. We know that the electric field is basically the dot product of E dot A. You could write it as EA cos theta. And using that thing, we can now understand Gauss law. Very, very important. Very, very, very important. What does Gauss law says that? To understand that, I'll draw a table for you. To understand that thing, I am drawing a table for you. Imagine that there is a table. On that table, I'm having certain charges. Let me consider that there are charges Q1, Q2, Q3. Q4, Q5, Q6. So there are so many charges which I am having. Okay. Now Gauss law states that if you need to find out, if you are considering a Gaussian surface, and I'm considering a hypothetical surface out there, this is basically a closed surface. I'm considering a closed surface. Do you know what is closed surface? It's like a packet. It's like a packet, a closed packet. Okay, like a closed packet. You are having like for a Lay's, for a biscuit packet, you are having, it's completely closed, like a gift box. Okay, so I'm having a complete closed packet. So according to Gauss law, if I need to find out the flux, the total flux, that total flux will be equals to electric field dot ds integration is equals to the Q enclosed in the Gaussian surface divided by epsilon naught. In this situation, this electric field is due to all the charges. This electric field is due to all charges. And this enclosed, Q enclosed, is due to the charges which are inside the Gaussian surface. Which are inside the Gaussian surface. Okay, so I hope that this point is clear. Now, now we are in a situation that we can go for the previous year. But before we move, I'm going to teach you that how we are going to apply this Gauss law. I hope that this thing is clear. If I'm considering an hypothetical, if I'm considering a hypothetical surface which is a closed surface, and if I need to find out that what is the Q enclosed here, that Q enclosed will be Q2, Q2, Q1, Q2, Q5, Q6. So in my right hand side, the charges will be, or I have to include the charges Q1, Q2, Q5, Q6. For the electric field purpose, I have to consider the all charges, even if these charges are outside the surface. That is the Gauss law. Okay. Tell me, is this thing clear? Let's move. Imagine that if I'm having a cube here, I'm having a cube, there is a charge Q. If somebody is asking that tell me that what is the net flux, the net flux here is, as the complete charge is inside the surface, so net charge is Q by epsilon naught. If somebody is asking you that how much flux is moving through a phase, so it's Q by 6 epsilon naught. And if you haven't understood it, I'm going to teach you some basics about the. Let me first tell you the basics about the cube. You know how many faces are there? Tell me how many faces are there in cube? 6. You must have played a dice game in which we have to use a cube, right? Like a Ludo, or Ludo is one thing in which we use dice. Another example is snake and ladder, right? Another example is business. There are so many things. I think that using this dice, we play so many games. Are you playing? Have you played any game using the dice? Tell me. Or you have seen only this dice in the questions only. So the number of faces I'm having in a cube is 6. The number of edges, if somebody asks me that how many edges are there, so 4 edges in the lowest layer, 4 in the topmost, 4 plus 4 8, and 8 plus 4 12. So 12 edges you are having. Another thing, if somebody asks you that how many vertex are there, so 4 and 4 8, 8 vertex are there. So there could be, like if I'm asking you that how many possibility are there, so there could be only 4 possibility, that if the charge is placed at the center, the net flux will be this thing, through one phase will be Q by 6 epsilon naught. And if somebody is asking what if I'm placing a charge on one phase, what if I'm placing a charge on one phase, and if somebody is asking that what is the Q net here, so Q net will be equals to Q by 2. Why? Because only half of the charge will go inside, right? Half of the charge will remain outside. So my value will be Q by 2 divided by epsilon naught, and I'll be getting Q by 2 epsilon naught. I hope that this thing is clear. Okay, now let's move towards another thing. There are applications of Gauss law, and using that applications you could be able to get the correct answers. Rambo Life, hello, how are you? How is it going? Are you able to understand it what I am teaching you? Is this thing clear, my dear? Please do let me know. Let's move towards the next thing, the applications of Gauss law. So using the applications of Gauss law, there is first one, if you are having a line charge, if I am having a line charge and there is basically, we know that a density is equals to mass divided by volume, right? A basic formula for the density is mass divided by volume. But here there is another term which is known as linear charge density. If I'm telling you a linear charge density, it means the charge divided by the per unit length. So lambda is equals to charge divided by length. So I am having a charge lambda is equals to Q by L. And if at a distance of R, I need to find out that what is the electric field at this point. What is the electric field at this point? If somebody asks you that find the electric field at this point, how you're going to do that? To get the answer, first of all, we will draw a Gaussian surface. We will draw a Gaussian surface, and using that Gaussian surface, we will apply the Gauss law. To get it, I could say that phi will be equals to E dot ds is equals to Q enclosed divided by epsilon naught. Right? Now, this electric field into what is the curved surface area we are having? What is the curved surface area? It's 2 pi r into h, right? So I can say that it will be equals to 2 pi r into h. What is h? The length. Q enclosed will be equals to lambda times of L divided by epsilon naught. This L will be cut by this L, and finally you will be getting that E is equals to lambda divided by 2 pi epsilon naught r. So this is the value which you will get. So here you can substitute that EP is equals to, if I multiply this with 2 and 2, you could write 2 pi epsilon naught r, or it's 2k lambda divided by r. Remember this formula, because this formula is very, very important. You are getting direct question from this. Let's see a real question from JEE 2024. Let's solve a question from JEE 2024. It was the question. One of my student was there in the 4th April shift 1, and after attending this question, he told me that, sir, I was expecting a question from electrostatic, and the question was very simple, because you have taught me graph in such a way that even if I do not know that what needs to be done in the question, I was able to mark the correct answer. I was happy at that moment. So please do mechanical properties of solid. Ragul, are you in class 11th, Ragul? I will do that. Please, Ragul, like you have to do a comment for that. This is a comment in the live chat, because it will not stay there. You have to comment on my video, particularly go on any of my video and comment there that you want a video or a lecture on this thing, mechanical properties of solid, so that I can show my team members that one of the student is requesting me to conduct a session on mechanical properties of solid. So I will consider that thing. Okay. I hope that this thing is clear. Now, see that my unique approach, as I told you that there are so many unique approaches which I use, which I taught to my student, and using those approaches, my student would be able to solve the questions earlier, easier, in an easier manner than any other students. What is the approach is, when you are dealing with the graph questions, you have to think in terms of the extreme quantities. My approach is, if you do not have If you do not have the plan, go for the extreme end, right? Here, I know that what is written here, that an infinitely long positively charged straight thread has a linear charge density lambda coulomb per meter. The electron revolves around a circular path having the axis along the length of the wire. The graph showing the graph, see, they are asking you that the graph that correctly represent the variation of kinetic energy of the electron as a function of the radius of the circular path from the wire, what it could be. So this is my positive charge. And if this is a positive charge at a particular distance, right? Okay. So the variation of kinetic energy of electron as a function of radius of circular path. So they are saying that if you are moving with this thing, so you tell me what could be your answer. As I know that if my electrons are moving, if my electrons are revolving, right? If my electrons are revolving, the kinetic energy will remain same. I told to my student that whenever you are solving any graphical questions, you have to think in terms of the extreme ends. And you know what? If I'm having an x-axis and the y-axis, the graph could only starts from these 3 points. The graph could only start from these 3 points. The A point, if my graph is having a positive value, the O point if my graph is having a 0 value, or a minus point if my graph is having a negative value. These are the only 3 points at which my graph could start. Tell me, isn't it? These are the only 3 values at my when my graph can start. So at this point, I'm seeing that would it be possible that if the particle is moving, can it have a 0 value? No. Can it have a constant value? Because this is a constant value graph. Yes. So the answer is constant value, right? Easily you can mark it. Now, again, okay, for this answer, I need to tell you another thing from the applications of Gauss law. Application of Gauss law. I hope that first application is easily be you know that how we are getting the electric field in a straight wire, in a straight thread like condition. Akhilesh, is it clear? Right? Now, if there is a sheet, second one, if there is a sheet, thin sheet I'm considering, if we are having a thin sheet, okay, due to this thin sheet, the electric field will be, let me consider a sigma here. Sigma is equals to the charge divided by area. So the electric field is sigma divided by 2 epsilon naught. Sigma divided by 2 epsilon naught. And if you have to draw the value of E versus R, it do not depends upon the R. So if it do not depends upon the R, I'll be getting this value, right? This is very, very important. Very, 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 very important, right? And once you know this formula, rock with N Naveen, beta, why I will be ignoring you? I haven't ignored anyone. I'm a kind of a teacher, who goes to the student. Why I would ignore you? Arey, have you sent me the message? I told you, right? Yes, I got you. Have you sent me the message? I told you after the class you have to text me, right? And you have to come regularly in my live classes. You are not coming regularly in my live classes. Like when the class is going to be finished, you are coming, like to disturb the class. If you want some money, you have to show the courtesy that I get to know that you are my student and you are coming every class. And if you have some issues, I will be there for you, right? I'll be there to help you, and I'll be more happy to help you. So you just need to come again in my live class, and once you are there in my live class, you have to text me. Right? I have provided you my ID. Now let's solve this question. This question is from JEE Main 2024, 4th of April, shift 1. This question says that there is an infinite plane sheet of paper. You are having an infinite plane sheet of paper of charge having uniform surface charge density plus sigma placed on xy plane. Okay. Another infinitely long charge having uniform linear charge density plus sigma E coulomb per second is placed at z is equals to 4. Okay. Plane and parallel to y-axis. First of all, you need to understand that what is happening here. You need to understand that what is happening here. This is my x plane, this is my y plane, this is my z plane. Okay. In your xy plane, there is some sheet out there, infinitely sheet, right? Infinite plane sheet is there in xy plane. So this is my xy plane. So this is my xy plane. Okay. So this is my xy plane, and this is having a value of plus sigma s. At z is equals to 4, at z is equals to 4, there is another infinitely long charge uniform. Okay, there is another sheet out there. I can draw another sheet using the red color. Okay. Parallel to the y-axis. Perpendicular. You can keep this thing as this much. And here z is equals to 4. Z is equals to 4. Okay. Now you have to get that what must be the value, right? Here you have to get if the magnitude of sigma s, this is having a value of sigma e. The value of sigma s is 2 lambda e. Then at point 0, 0, 2 x, y, z. That means at midway somewhere. Okay, at midway somewhere, the ratio of magnitudes of electric field values to the sheet charge to that of linear charge is pi under root n is to 1. Okay, the answer means if you see this diagram, this seems to be very difficult, but I'll draw a very simple diagram for you. The diagram is that there is a sheet out there. This sheet, and also there is another sheet. This is my sheet. This is my sheet. The difference between this and this is 4. Right? Because this value is at z is equals to 4. This is 0, 0, 0. This is 0, 0, 4. And you have to find out that at this point, consider this as P point. This is 0, 0, 2. Okay, you need to find out that what must be the value of electric field, ratio of the magnitude of the electric field due to the sheet charges to that of the line charges. Okay, now electric field, I would be marking this as E1, I will marking this as E2. Okay, now this E1 will be equals to sigma divided by sigma divided by you would be saying sigma divided by 2 epsilon naught, right? And due to this is also a positive charge, this is also a positive charge. So E1 will be equals to sigma S divided by 2 epsilon naught. Similarly, for E2, I will be having sigma E, right? Sigma E divided by 2 epsilon naught. Right. Okay. To the line charge is this. Okay. Now, in this, we have been provided that sigma S is equals to 2 lambda E. We have been provided that sigma is equals to 2 lambda E. Okay. Are you getting my point? Fine. Also, we need to find out one important thing due to this sheet to the line charge. Okay. So to get the value, basically we need to find out that first one is the E1. The ratio of the magnitude of the electric field, you have to take the electric field due to the electric sheet and to that of the line charge. Basically we have to just because of sheet and then because of line charge, I could write this thing as E sheet and E line charge, right? That is the surface charge density. They are creating a confusion. Confusion is due to that this is a surface charge density and the another one is a linear charge density. This is a linear charge density. So you know that due to the linear charge density, if I am having a line here and at a distance r, if I need to find out the electric value, that electric value will be equals to 2k lambda divided by r, right? This is what we were doing earlier. In the first application, we were doing this thing, 2k lambda divided by r, right? Similarly, you have to use this thing here. Okay, so you can replace this thing as sigma s divided by 2 epsilon naught. And you could do one thing, multiply by r divided by 2k lambda. Okay. I hope that this thing is clear. And now you have to solve it. Put the value of sigma s as 2. Put the value of sigma. Put the value of sigma as 2 lambda e. So that will be cut 2 lambda divided by 2 epsilon naught into r divided by 2 1 by 4 pi epsilon naught. I'll be keeping it as 4 pi epsilon naught. This lambda will be cut by this lambda. 2 will be cut by this. This will be cut by this. This will be cut by this. I'll be having r 2 pi. What is the value you are getting? What is the value you are getting? Deadline in 2 days, don't ignore. What deadline you are talking about? Which deadline you are talking about? Naveen, tell me for which deadline you are talking about. Okay, I'll be getting my answer as I'm getting my answer as 2 pi r, right? And the value of r is given to you as 2. So you could write it as 4 pi. So 4 pi is to 1 I'm getting. So I have to compare this 4 pi. I have to compare this 4 pi with this thing. I have to compare this 4 pi with this thing. Okay. To get the answer, I have to compare. Pi is there. 1 I do not need to consider. So my root n is equals to 4. So I need to get the value of n. So n is 16. Okay. So n is 16 here. I hope that this thing is clear. So in this case, n is 16. Okay. Now let's move. Now this question is from JEE Main 2024 4th April shift 2. In this question, a charge q is placed at the center of one of the surface of a cube. So if you are having a surface, if you are having a cube, you are placing a charge on one of the surface, right? One of the surface you are placing. So they are asking you that what is the flux? You know that flux is equals to that what is the charge you are getting inside divided by epsilon naught. So in that case, you will be getting 2 divide q by 2 epsilon naught. So that is my answer. Earlier also, when I was explaining you the concept of this thing, you got to know. Okay. I hope that this thing is clear. Shall we move? Okay, now let's move. This question is from JEE 2024 5th April shift 2. This is a conceptual question. They are asking you that the vehicle carrying the inflammable fluids like petrol usually have metallic chains. So if you have seen any truck, carrying a petrol in it, basically they are having a chain. They are having a chain which is touching the ground. So why we are having this thing? So basically it is to conduct excess charges due to the air friction to ground and prevent sparking. So this is to prevent the sparking. I hope that this thing is clear to you. This question is from JEE Main 2024. So Naveen, my ID is IAM_Manoj24. I'm writing my ID here. IAM_Manoj24. Okay. So that is my ID. Naveen. Fine. I hope that this question is clear to you. Shall we move? Now, let's move to the another question. JEE 2024 5th April shift 2. In this question, you have been asked that the electric field at point P due to the electric dipole is E. The electric field at P, where is P? P is here. Okay, so at this point, I am having the electric field at SE. Electric field at point R. R is where? R is here at an equatorial line at will be E by X. Okay. So it's basically the R distance away from the center point, and this is at a R distance. Okay. I know that E axial is equals to 2 kp divided by R cube, and we have been provided it by E. E equatorial is equals to kp by R cube, and here now R cube is 2R cube, right? So you will be having kp divided by 8R cube. Okay, you have to find out the at equatorial line that what will be the value. If I'll multiply this by 2 and 2, and I'll use this 2 kp by R cube, that will be my E. So I'll be getting E by 16, right? Wow. So my answer, because I have to compare this with E by X, it is equals to E by 16. So my X is equals to 16. My X is equals to 16. So I hope that this you got the correct answer. Right? Right? Let's move. Now you are seeing that the questions are very easy from this chapter, right? The most important factor is that which type of questions you are getting and are you able to solve the questions or not. So after attending this just one short lecture, you are able to answer the JEE Main real questions. So here in this question, sigma is the uniform surface charge density of a thin spherical shell. Let me consider a shell here. The radius is R. Surface density sigma at any point on the surface of the spherical shell. Okay. The electric field, basically it's asking you that what is the electric field. So my electric field is what? Sigma by epsilon naught, according to the Gauss law. So we are done. Now all of these questions which are there in this PPT are homework for you. These questions are from JEE Main 2024. There is a separate series I will take. In that I'll be only solving the previous year questions from JEE 2024, 2020. Like I'll be solving questions from JEE 2017 to 2024. Okay, now we will meet again in my next class, and do let me know that which topic do you want me to take in the next session. I am planning to take the current electricity because that chapter is very, very important, or I'll be planning I have two things in my mind. Either I will be taking the current electricity or the moving charges and magnetism. You can please comment in this video that which chapter do you want first to take me. And the second thing is that we are planning to launch a previous year question series. So do let us know that whether you are comfortable in that series or not. And the another scenario is that will you be comfortable in joining the classes live in the morning session? So do let us know that also. We will meet again in my next class. Till then, bye bye. And if you haven't joined our Telegram group, please do join that Telegram group. We'll meet again. Okay, Akhilesh, bye bye. Thank you for joining live.